We all know that technology plays a key role in addressing the challenges that are in front of us, and we need to collaborate with the vendors to make solutions happen. So in that spirit, we have a panel here to talk about the latest and greatest in technology and how they can help. So on the stage, we have Ajay Mannepalli, who is the Senior Director of IT Architecture and Strategy at ERCOT. We have Xing Wang, who is the Global Leader of Energy and Utilities, Amazon Web Services. We have Bøye, Industry Advisor, Energy and Utilities, Microsoft. We have Achalesh Pandey, who is the Vice President and General Manager of Innovation at GE Vernova. And we have Ravi Pradhan, who is the Vice President of Technology Strategy at Siemens. Ajay, it's all yours.
Thank you, Venkat, and good afternoon, everyone. I know it's the last panel of the day, so we'll try our best to keep everyone awake. So welcome to the technology panel. So as Venkat mentioned, we're going to be talking about some of the trends in our industry, and then how the vendors are incorporating that in their products and platforms. As we saw during the keynote and the various panel sessions during the day, we are at an inflection point in our industry with the changing nature of the grid. And the hope is that some of these technology solutions can help unlock the ability to solve these complex problems. So we'll be touching on things like cloud, AI, ML, data and analytics, APIs today in the conversations. So I have a great panel here with me, and I would like to kind of have each of them just kind of cover a few of the things they are doing as it relates to innovation. So Xing, do you want to kick us off?
Yeah, hello everyone. So I'm Xing, part of Amazon Web Services. So AWS actually is a technology provider. People know it for cloud, but actually it's I would say edge to cloud. We do have edge devices, on-prem, managed compute, and storage. And also we are, in terms of innovation, we are developing our own LEO, low Earth orbit satellite systems, which will be tightly integrated with our cloud infrastructure to provide coverage for underserved regions and people and business. So myself, my focus is grid modernization. That means that I work with our grid operators, utility customers, looking at business value, business cases to apply AWS technology to address real-world business challenges. So lots going on. I would just echo back to the last panel. I think Casey, I don't know whether he's still in the room, Casey from SPP. So we have actually been helping, working with Casey's team, looking at automate their generation interconnection modeling process. We're able to, working with our partner like Pearl Street Technologies, actually we were able to shorten the modeling process down to 1 hour, less than 1 hour, to create 62 scenarios that the SPP generation interconnection team to do all the studies, for different scenarios. The other innovation I want to mention is Duke Energy. So we have been working with Duke Energy's team, also looking at, I think Professor Overby mentioned that you need to, model a lot of weather-based conditions, and a lot of different scenarios for, investment decisions, right? CapEx decisions. And we worked with Duke Energy and is trying to help to enable they run literally 70 million power flows in 15 minutes using cloud infrastructure. This is where I think shows the power of cloud, and combined with domain expertise with our existing planning tools to be able to address the future cloud infrastructure planning problems.
Thank you. Doug?
Yes, so innovation is important, and Microsoft's overall purpose, if I was to summarize it, is to help people and organizations around the world solve problems and create value. And the way we do that is obviously by providing digital services. And the latest hot topic, has been touched on many times today, is artificial intelligence. We're seeing a tremendous demand for this technology across all industries. But for Microsoft, this basically means that we need to expand our physical footprint in data centers to be able to meet the ongoing demand. After AI, we will have an onslaught of what we can do with quantum computing. I'm pretty convinced that's not going to mean any less energy consumption. We are very much dependent on the success of this industry and its ability to deliver not just energy, but for Microsoft's purposes, clean energy. We have a goal at Microsoft to be running purely on renewable energy next year. By 2030, we hope to be net zero, which means that not only our data centers needs to be running on clean energy, but our entire supply chain and our procurement needs to be clean. So we want to work with all industries in their effort to transition, help do the energy transition. And then finally, by 2050, we want to have eliminated all the CO2 that Microsoft has released since it was founded in the 70s. And another big green energy consumption coming out of that. So we have a self-interest really to work with industries and try to help solve their problems. And with that, we have come to learn that partnerships are very important. Like it's come up here numerous times today as well, is that our ability to collaborate and figure out how do we collectively solve the problems ahead of us. I think that is going to give us the greatest odds of success. So kind of to wrap it up, Microsoft's involvement in this is we're a big consumer of energy. We innovate with the industry to try to help you solve the problems. And third, we are trying to influence the overall market in their adoption of renewable energy, and also work with regulators and policymakers on making the right infrastructure for us to operate within.
Thank you. Achalesh?
Yeah, hi, I'm Achalesh Pandey. So I am from GE Vernova. So recently, just last month, we spin out this energy company out of GE, basically called GE Vernova. So we are purpose-built for energy transition. I work in the electrification software business, and I will cover some of the technologies, innovation, which we are driving in software side, specifically grid software technology side. So first of all, to ERCOT team, like putting together this Innovation Summit is really great idea. And I personally learned a lot of things today. So if I look into what previous panelists talked about, there is high uncertainty. We heard about that. So that is driving large variability. Then second thing we talked about is a lot of DERs are all going to be on the grid, so it is driving high volume. And then third thing is that because of the extreme events are no more infrequent, these are happening very, very rapidly. So the velocity is increasing, both regulation side as well as extreme weather event side, as well as some of the needs of the technologies like synchrophasor data and other, that is increasing the velocity also of the data. The need to process that data, the velocity is also increasing. So what we are doing in GE Vernova is how to bring these high velocity, high volume, and high variability. What kind of the software tech stack is required. So you can think about from application layer point of view, like what kind of application do we need? We talked about high renewable penetration that is driving low inertia in the grid. So we are looking into predicting and forecasting inertia. So that's one of the innovation we have been working with, for example, National Grid ESO in UK, and that is optimizing reserve margins basically. Then there are other areas, like if you look into the extreme weather events we talked about, there are a lot of AI and machine learning application there. The nature of it requires a lot of weather information, it requires information from multiple sources, and this is the perfect use case for AI and ML. You are predicting the storm and the impact of those on the outages, and your goal is keep the lights on. So that's the another area. Third area is in the similar line, we are collecting a lot of images through LiDAR, or there are a lot of satellite imagery today. You can do the 3D reconstruction, and you are doing the vegetation management. You are trying to detect the trees around the power line, so that making sure that there is the trimming management, vegetation management is there, or as well as inspection. So that's the application layer. Now, if you go below that layer, that is your more AI or ML service layer here. The service layer is forecasting applications, for example. We are moving more towards the probabilistic forecasting. We are moving more from short-term to mid-term and long-term forecasting the needs where we are for the energy transition. And that is supplying to your distribution, transmission, DERs, market, every single place that forecasting. Second area is simulation. What can we do on the large-scale simulation side? So that's the another innovation area which we are driving. And if you look into the next layer below that is to run some of these orchestration you want to do. We are moving more and more towards container technologies, for example, Kubernetes and other things, making it cloud-enabled, cloud-ready, hybrid cloud-ready. So that's the another innovation on the enterprise software layer side. And the last thing, when we talk about AI and ML, I think AI and ML, AI is a tool, basically, that can help augment humans, our operators, our engineers. And if we talk about AI ML, data is the fuel for AI ML. So what we are doing, we are also doing a lot of innovation on the data side, whether we are connecting, it is our tech stack is basically GridOS, where we are connecting to different disparate sources, breaking those silos in the data which exist in the utilities, for example, in the federated manner. So that's the another innovation layer which we are driving in that kind of the space here.
Thank you. My name is Ravi Pradhan, and I'm from Siemens. Most of you are probably familiar with us because you're using our tools like PSSE and MAUD and NMS, at least in the Texas footprint. And we really are here to serve the needs of the ISO and all of you here. And leveraging the kinds of technologies, actually, like some of the other panelists have been talking about here. We're not the providers of those, but we'll use them and leverage them to provide better quality to you folks. So the topic today has been fascinating because it's been sort of a reinforcement of what we've been thinking and a validation of some of the stuff that we've been doing. But I think in terms of where we at Siemens have been focused on in the recent past has really been around DRs. DRs, both as transmission connected, distribution connected, and also, as part of that is everything to do with storage. We consider the DR problem essentially sort of as at two levels. One is, what's transmission connected, and in a sense, that is a simpler problem, right? That's the problem where you have high visibility because telemetry is possible. You still have to deal with things like variability and uncertainty, which people like Guillermo earlier had talked about. But it's, in a sense, it's a manageable problem, and it's one where we've taken great strides in already. We apply technology to that problem in a variety of ways. One is by doing things like using ML to try and sort out what to do with uncertainty, how to quantify it. But we also use technologies like the ability to do look-aheads, right? One way to try and avoid, to sort of avoid having to go fully stochastic route is to look ahead to see what's coming up and essentially smooth out your transitions, the behavior of your grid, what you're going to send out by looking ahead. To do that, it does require a high degree of parallelization and sort of, leads itself to think of why not go into the cloud and do some of that stuff. We're already solving these fairly large problems, for example, for the whole of the West, in quite reasonable times. As the variability problem becomes, if we need to deal with it by parallelizing further, given the inclination and the time, there's no reason why we couldn't do things like put it into the cloud for that. The second level that we look at, of course, is everything behind the meter. I think Sirajul or somebody from CalISO this morning mentioned, they have 14 to 17,000 megawatts behind the meter, which, they have a hard time they have no visibility tool really, and they have a hard time in terms of understanding what it's even doing behind the meter. So there is a whole domain there where there is low visibility, as Achalesh said, the volume of data is high, but the comms are poor. There's a whole domain there that needs to be tackled, and that's a key one that we're looking at, because we think that also has great potential for unlocking flexibility in the grid and being able to leverage it. Now, on that front, on the one hand, there's low visibility because of comms, because there's no real-time telemetry, but there is large volume of data. If you have smart meters, you've got tons and tons of data. Again, great fodder for feeding into tools and techniques that use AI and ML to help you figure out what you want to, how to understand what's going on behind there. It was interesting this morning when we were talking about demand response and managing load. There's so much about human behavior there, right? It's not just about what you want the grid to do or what you think you can teach people about the grid. It's, at the end of the day, it's about human behavior. And there are many other entities, fields outside of grids themselves that are taking lessons out of that. And it's based on data, it's predicated on data, and there's no reason why we couldn't leverage that for helping us manage the grid better. From an innovation perspective, I will be the first one to say that we're doing these things incrementally. At Siemens, we're doing these things incrementally. We have great partners, we have great clients who drive us to innovate, who are at the forefront of things, and we're making incremental changes. And we leverage our partners, right? We are using, for example, one of the ISOs, actually now two of them, are doing all their modeling in the cloud. At this point, it's based on AWS, but it was a surprise to see that an ISO would actually be open to that concept. And I think they've conceded, for example, that security, not to make a pitch for AWS here, but they conceded that security actually might be better on the cloud than it was on-prem. So we moved these things incrementally. We took our existing modeling tools, put them in the cloud. We're improving how much further and how much finer and more granular we can make our look-ahead studies. So all towards the end of, really at the end of the day, to make my long story short, is to leverage DERs, which are proliferating, storage, which are a subclass of that, towards helping manage the grid better. Sorry, I went on a little too long.
So I'll kind of pose a question. This one is around, we are in the age of AI right now. And so we already seen kind of the benefits of AI as it comes to productivity, whether it's end user productivity on developers with assisted coding. But where does the panel see us use some of these technologies in Right. So I'm just going to repeat. So we have seen kind of the benefits of AI in productivity use cases, end user and developer. But the question to the panel is, there are complexities with managing the grid. And how do you see these technologies play a role and enable the operator to make decisions? And how are you embedding these in your projects, at least the things that you can share?
I'll take a quick crack at it. The topic of storage was dominant today, right? And it's fascinating to me because last year I actually spent some time on the floor of an ISO sitting with an operator, and it really makes them nervous because we talked about how fast the ramp rate is and how quickly they respond and how it's so fast that it's almost unmanageable. That in itself sort of is begging to be managed in a more automated fashion, right? Literally, the human mind cannot grasp how quickly those things move. So it's sort of an obvious use case to use AI ML to be able to manage them better.
Yeah, want to add, I think first, I think we all need to appreciate the Gen AI created excitement, so I think that just kind of really bring that AI machine learning back to the front stage and under the spotlights, right? But if you look at AI, just maybe some concept, right? So AI is a bigger scope, right? And then under AI, you have machine learning, right? And under machine learning, you have neural network, deep learning, and the Gen AI really is a kind of deep learning, and large language model is a type of Gen AI. So I think when we talk about Gen AI, certainly everyone excited, but a lot of use cases in power system, in the grid, actually is kind of machine learning, right? And how do we use that in the control room, even in the planning world, right? I talked about we run millions of power flow. Then that is not a human task to set up the case, right? What scenarios? That's Gen AI case. What scenarios you want to study, right? You don't want to miss the critical scenarios. And looking at the result, what anomaly that you want to focus? The 70 million power flows result, nobody going to look at it, right? You really need to look at machine learning to look to see what's the problem that potentially you're looking at. And in the control room, we're already doing what-if studies. We could do more, but what-if studies we can do, right? We should do. And what result we can get so that we can create a Gen AI powered control room advisor. It's not making decisions, but it's a great decision support tool for our operators. Echo back to previous panelists, and this is very essential, right? Especially during the storm, during extreme conditions, they need to look at N-K contingencies in some of the areas. They need to pre-position, right, the generators and the network to deal with that. And what's the best? And this potentially could never happen. It never happened before, right? So it's not something that they have the knowledge about. So how do we address that? I think this is a great potential to create a large grid model using the generative AI.
So I'll make the claim. We've been kind of talking about the application of AI and how to think about it. We don't feel comfortable with allowing AI to make big decisions for us. I think that is a slight misnomer that we shouldn't rely on AI for decision making. So if you start at the lowest level, it's about what is the condition of the equipment. At that level, AI applications have been used for quite a while, right? We think in terms of predictive maintenance, we think in terms of equipment optimization, performance optimization. Those types of scenarios, it's easy to imagine that we will take the recommendation that the system gives us on how do we tune those and how do we maintain them. And then you go up at the system level for an asset, for example, or a distribution grid or transmission lines, and say, okay, what are the types of things that we need to understand? Because this is all about using computers to increase the signal-to-noise ratio and perhaps remove the noise altogether so that we as human beings can apply our skills, our knowledge in a way that is most impactful to the mission of our organization. So that is kind of how I think about machine learning. And then obviously we have generative AI that has come up over the past year and a half or so and kind of brought AI to the forefront of everybody's imagination of what it can do. And the way to think about that is really, it provides you with a new form of interface to computing. And especially with the recent announcement where you now have multimodal solutions where the AI model can understand what you're saying, they can see you, and they can see your environment, which presents brand new opportunities that we haven't quite imagined the impact for yet. And then on the back end of that, we have the large language models, which is basically take a neural network and feed it with as much information as the use case warrants, which could in some cases be the entirety of the internet and the collective information that is publicly available, or it can be something that is a much smaller piece that is very specific to the use case. So for industrial applications, for example, you can create large or smaller language models that are an expert within a very niche domain. So I think there's all kinds of untapped potential around artificial intelligence. I think it's going to have an increasingly higher impact on our lives and how we run our business going forward. And I think only time will tell how quickly it will help us achieve the goals of the grid.
Yeah, I think AI is already significantly being used, specifically in the generation side, actually. But you can divide AI into 3 categories. You can say it is detection problem, whether it is time series data you are getting from the sensors, from your SCADA system and other, you are detecting anomalies, you are detecting alert. Today, everything is rule-based system, deterministic system, but AI can be used for early warning prediction. The detection time is much earlier. So that is one sort of the problem in the predictive maintenance, but same technology can be applied in the future. We are calling it a virtual operators. Like it is digital assistant to the operators, and it is continuously bringing the situational awareness as the things are changing dynamically in the grid. It is detecting those changes. It is the pattern recognition technology, just like we use the fraud detection in the financial industry, or same thing in the predictive maintenance application, same thing can be applied. We talked a lot of things about the oscillations because of the IVRs which are happening in the grid. So you can do the oscillation detection, you can do localization, you can do root cause analysis on that. So AI is pretty good in doing some of those things. So those are good use cases. Second use case of AI is in the prediction area, where you are trying to generate the deeper insight. You are making the predictions, like you can do performance prediction, emission prediction in the generation space. In case of the grid in the future, you are going more state estimation problem. Today, we are using PowerFlow to do the state estimation, but that can be augmented by bringing some of the AI technology, specifically in the distribution grid, where the things are dynamically changing, network model is changing, so accuracy becomes challenging there. So that's the prediction side. And then third problem is the optimization, decision support, controls kind of the application. That's the much more longer horizon, difficult problem to solve. We are seeing so many problems because the problem is becoming complex. Complexity is increasing in the grid. Volume is increasing in the grid. Uncertainty is increasing. So if you want to run a lot more cases, you want to do the contingency analysis with several scenarios, you need your fast optimization engine. So that's another area where technology is going, where AI can augment the traditional optimization methods. Because it can run much, much fast. Like some of those optimization can run in the machine learning based approaches based upon the data can run in seconds. So you can run much more scenarios. So that's where I see. And then the generative AI can be used to bring data from various places. I think we are experimenting or using generative AI across enterprise, basically, not just for the productivity for code assistance and other places, but also looking into various kind of the documents. So your RAG methodology we call is retrieval augmented generation. So in that, you can have the contextual information for your document. So same thing is applicable where you can have user guides, you can have several other documentation. If you do the intelligent prompting, you can get a lot of value. And then this will truly become a digital assistant for operators, actually.
Mm-hmm. Thank you. So I'd like to talk a little bit about cloud computing. And we already talked about some of the benefits, but what are the challenges with adopting cloud? And also, maybe you can cover a little bit around some of the regulatory constraints that we have in that space.
Challenges. I think cloud is still relatively new to the utility world, right? To the grid operators, especially. I think it's one thing is the trust that we need to earn the trust, right? I think, and also we need to drive the cloud adoption through very clear use cases, business value, right? So and I think it's getting very, very clear. So certainly there's a I wouldn't say, I think back to Ravi, you mentioned that the cybersecurity is actually better in some cases, right, on using cloud than on-prem. But, really the concern is the compliance, right? We got NERC CIP, which is defined years ago, and so some of the languages, people just don't have a clear understanding what is in NERC CIP scope, what is not in the NERC CIP scope. And good news is industry have been working with NERC on looking at what CIP is going to be evolving, right? So end of last year, there's a white paper being published by NERC site working group, even looking at critical system like EMS, how do we decompose that monolithic system into different applications and look at maybe SCADA will continue sit on-prem for a while, but in application like contingency analysis, or unit commitment, or this type of computing heavy, dense applications can move to cloud. And NERC actually is asking the industry to submit SAR, which is standard authorization request, to NERC. So, which means that they want to know the use cases for the cloud adoption that just really bring value to the industry, and NERC is considering those for the future SIP revision. So I think there's potentially challenge, but I see that because of the business needs, right, and the need that we mentioned the whole day is to be able to leveraging high performance computing to do more studies, and high performance computing goes side by side with machine learning, because without machine learning, AI, you cannot really actively leverage high performance computing, and all of this means that cloud will play a key role for the future grid planning, forecasting, and operations.
Yeah, I would just add appreciate the potential learning curve for cloud adoption. Obviously, you have software as a service, which is just flip a switch and consume, and you have PaaS services, which are building blocks in the cloud that allows you to build your own solutions, and then you have more sophisticated combinations of technology that's available. So appreciate kind of the need for your organization to understand not only how to deploy and build your capabilities into the cloud, but also how do you operate it, and how do you think about the resilience of those applications as they are running in the cloud, as they normally would have a significantly different approach to that compared to what you would do on-prem. But in terms of challenges, I also think that we have an opportunity, and Xing touched on it earlier. We understand the need for more flexibility in how you adopt the cloud, which is why both AWS and Microsoft Azure is providing what we call edge capabilities, which is in short a set of cloud capabilities that you can deploy into your own infrastructure and allow that to be managed as part of your overall cloud portfolio. And it does now provide you with the ability to provide communication between your OT environments and the cloud. It provides you with the ability to run compute workloads on the edge, like AI models that can provide you with insights into your IT space. And it also provides a wide support for standard industry messaging between the OT environment and the cloud. So we are kind of facilitating this transition to cloud adoption, both through working with organizations like NERC to make sure they understand how do we come up with a collective response to how cloud can be adopted, as well as kind of moving the cloud capabilities closer to where it is needed.
Thank you. So another important part as part of this grid transformation journey is data. So how do the fundamentals of data management, data governance, data quality, what role do they play amidst this AI ML revolution that we are seeing?
So I'll take a crack at that. I think, again, I'll bring it all back to DERs again. Data management, think of it from a modeling perspective. You're not going to wait for half a year to get a project approved. So, when I think of data management and I start out with model management, it all becomes about how efficiently you can get your modeling done. And again, this is an area where having resources in the cloud are something you can leverage because, for example, we do PSSE in the cloud, which means you can leverage all that compute power to be able to run your studies much faster than you would if you had something on-prem. But also with the ability to put all of this information in the cloud, it also taps it also unleashes, I guess, because we haven't done this yet, to be honest, is the ability to actually figure out, how to clean up your model, validate your model, how to make the whole model building and validation process much more efficient, right? Again, this is a combination of leveraging the services that are available in the cloud and making use of AI and ML to essentially be able to do even the simplest things, nothing terribly sophisticated. When you're building a new model, detect, where there could be the error, possibilities of introducing error. So I think from that perspective, putting all this modeling capability into something as resourceful as the cloud is a great advantage.
So I agree with Ravi on that. But I think another point here is if we look the problem like from right to left. So right means what are the business outcomes you are trying to drive? Suppose your business outcome is reliability, your business outcome is cost, productivity, affordability. Then to deliver that business outcome, what kind of the models are required? Whether these are analytical model, physics models, or these are machine learning models. And what kind of the accuracy and fidelity is required based upon your use case. Now, to build those models, what kind of the data is required? And the key problem there is accessibility challenges in the data. In the utility space or even ISOs, data is sitting in silos, different places. How to break those silos? How to get the access to that data set seamlessly? Second problem in the metrics in the data is the accuracy of that data. Even if sometimes your use case requires some specific parameter, you may have a lot of data, but 2 parameters, suppose you don't have and you can't make that prediction, that's another problem. So machine learning models or any other AI models are not going to work. So understanding those aspects is also critical, and that's why the governance of the data is important. And then governance happened, this data is generated by 2 things, people as well as process. And when there is no good governance in place, then at the source itself, you are generating the bad data, essentially, the quality issues. And many times we have seen in the industry, based upon my last 20 years experience in this space, many times we blame machine learning model or AI model. The problem is not that with the model, the problem is with the data, whatever we are feeding to that. And so that's why I think having some of the, how to break the silos in the utility or in the ISO and other space, how to connect those data sources, bring it, how to do the federated data query. So you need not to move the data. Otherwise, it is becoming a massive project for you, right? And then making the right amount of the right quantity of the data available for training these models or when these models are running for the inferencing purpose. So data governance plays significant role there. I think we should also learn this from, given that we are very mission critical in this grid or market, that kind of the industry, we should learn from healthcare industry. In healthcare, there is a lot of regulations are in place, FDA, and there are a lot of AI models are getting approved by the FDA actually. And there is very specific requirement of data lineage, for example. You need to know this model was built on this data set, you should be able to track that. That comes from the different tools, different governance methods. So yeah, there are several kind of the tools and technologies are available today which can be leveraged for this purpose, but it's all about people, process, how to embed all those things as a part of the process. That's what also we should keep in mind.
Yeah, I just want to add to that. I agree with all of your observations, by the way, and I think that is one of the probably good value cases for cloud adoption is looking at how do you establish and manage a unified data estate and all the capabilities you talk about. How do you connect federated data? How do you create a information model across your data state that ensures that you have access to all the information that is relevant to you? And how do you build the insights and the AI models and provide those as a service both to employees and potentially to partners as well? And I think in terms of APIs and integration of all this information, because it seems like there's no single entity within the electric grid that has all the information that everybody needs.
One more thing, a point I will make, like we talk about most of the time tech debt. We don't think about data debt. So that's another thing we need to think about actually.
On that note, actually, it struck me that there is so much data available for training, right? I mean, think of it. Any of you who work at an utility, you've got at least 7 years worth of history, right? You've got save cases, you've got so much data that is such a fantastic corpus for building the kind of operator-assistive tools, right? You know, you've been in the control room when something doesn't converge. Okay, you got 20 minutes. What a wonderful way to make use of all that history that is contained in all those save cases to train a machine to at least give you suggestions and say, yeah, you might have a voltage issue here, or something. But all that information is contained in there, and like I said, everybody's got at least 7 years worth of data. And it's our fault, collectively, that we aren't actually tapping it more, my opinion.
So that actually kind of lends itself nicely to the next question. So from a vendor perspective, what are we not doing, or what should we be doing as an industry to keep up with the innovation that's coming in your products and platforms?
I can start. So I think and innovation is kind of the topic of today, and the single biggest responsibility for the power and utility industry is obviously to deliver power, and that is an operational effort. But at the same time, we recognize all the changes that are coming, that we're kind of in the midst of already, which means that we need to be able to change how we do things, which requires the ability to innovate. Digital will be a key ingredient in the solutions that's going to help us solve the problems, which means that you kind of need to develop the internal muscle of driving experimentation, be willing to try things out, and do not let perfection get in the way of progress. Be willing to explore and kind of see what are the types of things that perhaps happens in other industries, patterns that might be applicable, and try things out.
Yeah, I'll just add, similar, be more agile, right? And I think we do a lot of, as industry, we do a lot of proof of concept, which is great, right? That's part of the innovation. But I think at the same time, also we need to think about, from proof of concept, how do we get into production very, very quickly, right? And demonstrate the value to business so that people. So I really like Venkat's job title, that DevOps is the key, right? It's like really, how do we get the result delivered to business? And I think for AI machine learning, for example, you really need to assemble the right team, right, to have the domain. So when you do the innovation, the business has to be involved. So you need to have a subject matter expert, especially for Gen AI machine learning projects, right, who understand the business, understand what's going on, being willing to convert that knowledge, working with a team, with data scientists, and then you need to have a strong IT, right, to get the right data, right infrastructure set up for the success. So I think that's all required, and then be more agile to deliver that stuff, right, and require certainly our partners, our industry expert to also work with us, right, to do that.
Mm-hmm. So I agree with Xing on that. Like people use some of the AI ML as a hobby. We build the model, we build the prototype, but it never goes into production. So having the rigor of DevSecOps, I think that is critical. And it is more critical for some of the AI and ML models because these models continuously learn, adapt with the data. These are not deterministic. Second, and then having the very strong data foundation using the APIs and other things is critical. I think upskilling is also another important thing because not many people are conversant with some of these technologies. That is very difficult to hire, and then ramp up time is also significant there. So I will say these are various things I think we need to move the industry forward.
I think we at great risk I say this because we think of the industry as being conservative by nature, right? Which I think is to some degree a break. And as vendors, one of the things I think we could probably do better is be more aggressive in terms of pushing some of these ideas. Obviously, at the end of the day, the end users and the customers have to accept it and agree to do what we're pushing. But I think there is room for us to be more aggressive in terms of pushing some of these things forward a little faster. I use the phrase, it's the inexorable, move of technology, right? 12 years ago, did you think you'd be watching movies on a device that big? You didn't, right? But it happened. And it's the same way with all this stuff we're talking about now. I mean, cloud, it's very slow. It's making its move in, but very slowly. AI, ML, very slowly. I think it's somewhat incumbent on us as vendors to try and push that a little bit harder, and I'm sure we'll get pushback from those of you sitting in this room, but there's no reason why we shouldn't, to try and move things along a little bit.
Sorry, I just add one thing. I think be more standardized. That's probably one thing.
Yes.
Also to help the industry move faster, because we know that ISO RTOs are some great customers, but they all have very specific needs, right? How I need to run Powerflow this way. I don't want to run that way. I want the button to be here, not there. So those are making this guy's life harder to do this.
No, I couldn't agree more, because actually I was thinking earlier this morning somebody talked about interoperability, right? Yeah. I think that's one of those things that was very much in vogue 10, 15 years ago, and it sort of, comes and goes. But I think one of the areas that does, and this is something that probably needs more of an aggressive push from the end users than it does from vendors, because vendors are, if it's not interoperable, it's really not my problem. But to move the industry forward, I think it's key that the end users really push and say, let's make sure this does really, interoperate. Let's only have one version of the SIM that's going around, and not, 6 different versions. They're all SIM, but slightly different.
So I'd like to, I think we covered everyone. So are there any questions from the audience?
Yes, we do have, and it's a age-old question for sure, right? Our cyber and compliance says no cloud due to security or NERC reasons. How can you, the panel, help me communicate to them? And because of that, it's putting our systems and technology 10 years behind.
So, Xing, do you want to?
So I just wanted, so how do we help to communicate?
Right.
Yeah, so I think we're very, very happy to, right? So I think, first of all, just come to us. We have actually a dedicated team working with NERC, SIP, actually we're a member of NERC as well. So we actually, really spend tons of time working with them. And we're really happy to work with you. First, understand your business challenge, your use case, right? And looking at your risk model. And then we can help to communicate, what's the standard, what that means, and also communicate back to help you communicate back to NERC in terms of request for protocol changes. So very happy to do that.
Yeah, I don't think I would add a whole lot more than I think it's more an exercise of building a mutual understanding than it is to make a whole lot of changes to the technology that's already available. So if we have lagging regulation, it's a matter of helping them understand what are the mechanisms at play in this new world, and how do we ensure that it meets the objective of NERC as a whole. And if language change is needed, then we'll help them develop that.
Yeah, and I'll also add that it's again like NERC's ruling also is very specific, which one is 15-minute impacting, and so maybe also convince it that way. It's like which systems should really fall under that criteria. Any other questions, Venkat?
There's a question about, can you provide any examples of how data federation and the unification of that and providing the data lineage helped with some specific use cases?
Yeah, I think there are several use cases. Let's talk about extreme weather event. Like, you need to run the contingency analysis. You are collecting the data, you need the forecast, whether it is short-term forecast or long-term forecast. You are getting the weather information, you are getting the information from your EMS system, for example. When you talk about the future of the grid, you need to do a lot of T&D coordination also in the future. So getting the data from different systems, whether it is these are the third-party system or different silos which are sitting, You are talking about outages. You need to get the data. Outage data is sitting somewhere else. You are getting operational data that is sitting somewhere else. And then you have the forecasting, how to bring all these data sources together to make some of the predictions and then some of the decision support systems. So this is just one example, actually.
Yeah, just to add to the lineage part of the question. So if you're exercising on advice for this model, and let's just say there was a lesson learned from that decision, you need to be able to verify that the decision came from the sources that you believed, and kind of give it an opportunity. How do we make improvements in the ability to execute that model going forward?
I mean, some of the, probably more domain-specific sort of federation examples, which we see in many places now, is essentially being able to pull together planning data, for example, planning and operations, overlaying them so that, sorry, I seem to be obsessed with the topic of modeling today, but in terms of coming with better models or consistent models across the board, feeding the silos and because the truth is, as much as we as vendors are trying to bring these things closer together, organizationally, most of the folks are still separated into planning and operations, for example, and then markets as yet another, and customer service as yet another. So we want to pull that together. And I mean, I think the concrete example, probably for me, the best example is really in the markets, right? We're pulling together data from the EMS. We're pulling it from the weather services, from load forecast. We're bringing stuff in from your transaction scheduler, from your outage management. We truly are bringing all that stuff together. We just need to be able to do it better, I think. I mean, there are some places where we're doing it pretty well. There are other places where I think we could do a much better job. So that overall, again, you're still meeting that objective of coming up with good optimal solutions, good reliable solutions, right? That's what we really want to do at the end of the day. Hope that helps.
Thank you. So I think we'll, in closing, partnership with our vendors is key. But IT fundamentals still remain, whether it's with AI, ML, data, cloud. So I'd like to thank the panel for a great discussion.
Thank you.